Hello and welcome to the AI Research Roundup. I am Alex. Today, May 8th, 2025, we are looking at Ming-Lite-Uni, advancements in unified architecture for natural multimodal interaction, from Hugging Face's trending papers list, published just 3 days ago. This paper presents Ming-Lite-Uni, an open-source multimodal framework, a system handling images and text. It uses an autoregressive model, building content step by step, to unify vision and language tasks. This involves a fixed multimodal large language model, or MLLM, a language AI also processing images, and a learnable diffusion model, an AI for creating new high-quality images. Alright, so Figure 1 gives us a fantastic visual overview of what Ming-Lite-Uni can actually do. We see impressive examples of image generation, like creating a portrait or a toaster just from text. Then, there is image editing, such as making a horse gallop or adding a teddy bear to a scene based on commands. And finally, style transfer, transforming images into various artistic styles like abstract expressionism. The figure even shows a little demo of an interactive chat. This really showcases the system's versatility in handling diverse visual tasks through natural language, a core achievement highlighted by the authors. Alright, so Figure 2 dives into the framework's design. We see the fixed multimodal large language model processing inputs into multi-scale queries. These capture visual information at different detail levels. These queries then go via a connector to the diffusion model. This model uses diffusion transformer, or DIT, blocks, specialized units that learn to generate images by progressively removing noise. Crucially, multi-scale representation alignment ensures these generated visuals match the multimodal large language model's understanding. This allows for high-quality image generation during the inference phase shown on the right. Building on how the multimodal large language model guides image generation, Figure 3 now zooms in on the training strategies for this core autoregressive component, the M2 Omni model. Okay, so it illustrates two main approaches for training: the multimodal step balance strategy and the multimodal multitask balance training strategy. Both diagrams show the M2 Omni model processing diverse inputs like text, image, video, and audio. The multitask strategy, for example, uses historical validation losses. These are scores indicating how well the model previously performed on new data to adjust modality weights. These weights essentially fine-tune the learning emphasis on each data type, ensuring robust understanding. Following those training details, Table 2 presents some solid evidence of performance, showing quantitative results from parts of the Open Compass multimodal leaderboard. This is where we see how Ming-Lite-Uni stacks up against other models, including well-known closed-source ones. The table lists various benchmarks like MMB, MMS, and MMMU that test multimodal understanding. Ming-Lite-Uni, which handles both understanding and generation, shows really strong scores across these tests. This really backs up its capability for robust understanding alongside its generation abilities we saw earlier. Okay, so after looking at those strong quantitative results, Figure 7 then gives us some really compelling visual examples of instruction-based image editing. We see a whole range of before and after shots, like changing a cat to a squirrel, making a dog sleep, or even replacing a pizza with a cake, all based on simple text commands. These qualitative results really bring to life the generation capabilities discussed, showing just how fluently Ming-Lite-Uni can manipulate images based on natural language instructions. This is a great demonstration of its practical editing prowess. Now, building on those visual editing capabilities, Table 3 here evaluates the model's text-to-image generation performance. This is done using the GenEval benchmark, which is basically a standardized test that measures how well different AI models can create images purely from text descriptions. Looking at the results, Ming-Lite-Uni achieves an overall accuracy of 0.62. This is a strong showing, especially for a unified model that handles both understanding and generation, outperforming several others and holding its own against some top-tier systems. This really highlights its robust image creation skills. So, after seeing its strong performance on the GenEval benchmark for image creation, it is clear this work on Ming-Lite-Uni successfully creates a truly unified AI. It combines deep understanding of media like text and images with impressive generation abilities, all in one autoregressive model. An autoregressive model just means it generates content step by step. This system uses a fixed multimodal large language model, or MLLM, an AI trained on diverse data types with a fine-tuned diffusion model. Its open-source nature is also a key contribution. Well, that wraps up our look. Thanks for joining, and see you next time.